You can see the screen. Okay, so today we actually going to review this Unit 1 test. Okay, I'm not going through the detailed video, but we're gonna just go ahead review the whole thing. So if you look at the calendar here, okay, let's see. If you look at this calendar here, the test 1 is due by Monday. Okay, so it's coming up in here. Today's the 6th already, so it's due by Monday. You can do that by Sunday, but Monday will be the last day to complete. All right, so we finished the chapter 1 last class, and hopefully you go through the chapter 2 on your own. We're gonna go ahead and review that. So even if you didn't quite finish, hopefully this review will help you to kind of get through everything, which is kind of include the concept and technology that you need for this test. Okay. All right, so let's go ahead start from the first one. The first one, of course, it will be still the the chapter 1 in here. Okay, so this one right here, identify the data set label of the measurement hair color of a woman on the high school team. So you have a NOIR, right? Nominal, ordinal, interval, ratio, and then trying to see which one will be the key thing. Okay, anyone give me a quick solution?
Nominal.
Okay, all right, nominal, that is the correct answer, right? Because this one you cannot tell like which one is better. So that's the most basic one, that's the nominal. All right, the second one here is the age. Okay, this one is to determine a population or sample. The age of every fourth person entering in a department store.
That's a sample.
Okay, that is right. That is a sample, right? Because it only it didn't determine everyone. It only have every fourth person entering the department. All right. So this is a sample. And what kind of sampling technique you use in here? Anyone knows? That is not on the question in here, but I'm just asking additionally. So what kind of sampling technique? Anyone kind of get an answer? What kind of sampling technique is used in here?
Are you looking for like statistic?
Right. What kind of sampling technique? We call it sampling technique, which we're gonna have that later on. The sampling technique with cluster, stratified, systematic, convenient, or random. These kind of thing. Okay, so since it only survey every fourth person and it's pretty consistently, so this is called systematic sampling technique. All right. So yeah, when we say the sampling technique will be this one right here, like a cluster. Look at this one, number 8. Every fifth person boarding the plane, the airplane is searched thoroughly. So this kind of technique is called what? Systematic. Same thing in here, right? So I just ask a little bit ahead in here. Okay. All right. Let's look at number 3. The data is qualitative or quantitative. The colors of automobiles on the used car lot.
Qualitative.
Okay, that's qualitative because it's just the color, right? You cannot really measure using number to measure that way. Okay, number 4, this one is identify a data set label of measurement. So label of the measurement, same thing, similar is NOIR, nominal, ordinal, interval, or ratio. So temperature of 73 sedated refrigerators. The temperature.
Interval.
Yes, we said that earlier, temperature should be an interval label, okay? And how about number 5, the final grade, A, B, C, D in a statistics class. So that means if you have a 90 or 99, you all got an A, right? And then if you have a 70 to 79, you all got a C. So this kind of label, the measurement will be which one?
Ordinal.
Ordinal is correct. Okay, all right. So because this one, A is better than B, B is better than C. So you know which one is better, but it didn't have a really detail, right? It doesn't have a very detailed that you can, um, do the like a exact calculation, basically. All right. Okay, the zip code, list of zip code for Chicago. So which level of the measurement? Anyone? Well, zip code, even a zip code, you have seems like you have a number, but can you add or subtract that number for the zip code? Or does the number, the difference or the addition making any sense?
Is it nominal?
Yes, that should be a nominal because even you add or subtract for those numbers didn't really have a meaningful million that way. It doesn't really make sense, for the zip code addition. So it's just a nickname for the location for Chicago, right? So that's a nominal. All right. Okay, number 7, a poll is conducted in which professional musicians are asked their age. Is this observational or experimental study?
Observational study.
Why is observational?
Because they're taking a poll to get an observation based off the group of people versus an experiment would make sense to me.
Right. So basically, the research did not do anything different to this, whatever the musician, right? Just ask their age. So this is only observational. It did like it's experimental study. We make something different, like say a fertilizer, right? This piece of the crop you use a fertilizer, the other one you didn't. So something they make something different. Those are experimental, right? This one and then same thing as a drug. Some people take a sugar pill, some people take a real drug, and then trying to compare the outcome. So those are the experimental because they did something different. All right. So this one is just observational. Number 8, every fifth person boarding the airplane is searched thoroughly. So we said earlier, this one should be a what? Systematic. Okay, systematic in this one. Okay, number 9, a research randomly select and interview 50 male and 50 female teachers. What kind of sampling technique is used in here?
Stratified.
Okay, that's a great one. Stratify is exactly right because in order to get exactly 50 male and 50 female random sample won't be able to satisfy that. Okay, so they must separate into male and female group first, and then go to each group to randomly select 50 of them. All right, so this is a very stratified that way. Okay, number 10, to avoid working late, the quality control manager inspect the last 10 items produced that day. What kind of sampling technique is used in here? Well, apparently to avoid working late, all right? So they only inspect the last items. Apparently this one is called convenience. Okay. This one is not a good sampling technique, so we usually try not to use them. But this kind of sampling technique, it is called convenience. All right. That this one won't produce the really good outcome. So that is convenience survey sampling technique. All right. This is not a good one. The rest, the systematic is good, stratify is good, cluster random, those are all good, but not a convenience. All right. Okay, number 11, you want to use this table to answer 3 questions here. The first question here you need to answer here is class width. Class being point to the first class boundary of the first class. Okay, so you will need to choose A, B, C all correct in order to make this big A, big B, or capital D, C, D in here. Okay, so let's look at the first one. What is a class width? Or what is the class width in here? So what is the class width for this one? Okay, so the class width, I hope that everyone go through this chapter 2 already. Okay, this is a very fast pace of semester. Uh, it says 7 weeks, but this is considered week 2 already. Okay, so we still have to complete like the requirement by the coordinating board. And as I said earlier, I already cut to the very bare minimum that we cannot reduce anymore. All right. So, but you still have to go through like this, um, you know, as the schedule. Otherwise, you won't be able to finish. Okay. The class width
Is
here.
it 3?
Yeah. Okay. The class width is using the second class lower label. This is called a lower class label, right? Lower limit. And then this is a lower limit. All right. So you were using the 53 minus 50, and then we're giving you 3. So the only thing A is 3 is this one or that one. Okay, so this the first one is incorrect. So C and D already incorrect, right? So I only answer the first one. I already exclude 2 of them. Okay, so you use 52 minus use 55 minus 52 is also 3. One table can only have one class width. So if you use the higher upper, this is called upper class limit, you have to minus the previous upper class limit. All right, so if you use 64 minus 61 is also 3. So this table is very scientific. All the one table, the class width is the same. Okay, if you use 62 minus 59 is also 3. So it's very consistent in here. All right. Okay, let's look at the B here. Class being point of the first class. How do you find the first how do you find the class being point of the first class? First class will be this one. 50 to 52, right? That is the class beam point. So the formula for the class beam point here is using the what? Using the upper label plus the lower label and then divided by 2. Okay. There's also one page of the formula that you can use on the test. I think I posted on this one right here. Let me go to show this one to you so you know where. If you go to the modules right here, the key formula, okay? So everyone can print out this page of the formula sheet when you do the test. For the test one, you only need a page one, okay? Only need a page one is enough because we only have a chapter 1 and chapter 2 in a test 1, and this is enough. You don't have to use anything else. So for this test, you only need this one page. All right. Class beam point, you use the lower class limit plus upper class limit and then divide it by 2. So that is the definition. So you use 50 plus 52, okay, and then divided by 2. So that's 102 divided by 2. 102 divided by 2, we are giving you 51. All right. So if you look at B, they're both 51 in here. They both are 51. So you cannot identify this one. So that means you must understand the C in order to choose the correct answer. So C here is the class boundary for the first class. So what is the class boundary? The class boundary here is, since we have an integer, so the class boundary here will be plus or minus 0.5. Okay, plus or minus 0.5. On the lower class limit, you using, so for C, on the lower class limit, okay, lower class limit, you use 50 minus 0.5. All right, on the upper class limit, you use 52 plus 0.5. Okay, so this one we're giving you 49.5. And then the other one, we are giving you 52.5. Okay, so 52.5. All right, so this we are giving you like the called the class boundary. All right, so the class boundary here will be 49.5 to what? 52.5. Okay, so that is your answer. So the correct answer should be B. All right, the rest are all wrong. Any question about this one? So basically, this question 11, you answer 3 different questions. Okay, you answer A, B, C, and then you choose the capital A or capital B and C and D. All right. So this is one question. Actually, takes you 3 smaller questions in here. Anyone has any questions? All right, let's move on to question number 12. Use the OZI to approximate the number in a sample. So first, you have to know what is the OZI graph, right? So even we don't test you, exactly making the graph on the test, but you need to be able to read the graph, okay? So for the OZI here is what? The OZI here is the cumulative, okay? This is a cumulative graph. So basically the last one, the last number is the total number in a sample. Okay, so let's see how much is the last number. This look like this one. Oh, not quite straight. All right, so this looks like the last number in here. So looks like this last number here is about 80. Okay, about 80 in here. So that means the number in a sample should be 80. Should be 80 in here. I don't think there's 100 in here, right? This one, if you use a ruler, you can kind of approximate this one right here. So it looks like 80. Okay. So that's the ozai. If you know that, it's pretty simple. Okay, number 13, use the relative frequency histogram to first identify the class with the greatest and the class with the least relative frequency. All right, so relative frequency first, you have to look at the vertical bar here. This vertical bar here is called a relative frequency, right? So the vertical bar in here, and the greatest one, the greatest relative frequency will be this one. This one will be the greatest. So this one is about 0.35. Okay. And what is the least one? Well, if you look at this one right here, this looks like the least one right here. So this one is less than 0.05. All right. So you can give you an estimate. This one is looks like more than a half, right? So I will estimate this one probably 0.04. Okay. Even you estimate into 0.03, I think it will be still okay, because you cannot really tell the exact answer. But as long as you estimate is more than 0.025, which more than a half, that should be all right. Okay. Oh, the first one is identify the class. The second one is trying to answer the greatest relative and this relative frequency. So I just answered the B. Actually, I haven't answered the A. All right, so A is identify the class with the greatest relative frequency. So we know this one is the greatest relative frequency. And where's the class? Well, this class here looks like this has a beam point right here. And then this beam point to this beam point is 100, 110. So this one must be 105, okay? Because that's in the middle. And then same thing, this one must be 115. All right. So my class with the greatest relative frequency here is from 105 to 115. Okay. And the least one right here, this will be 145 to 155 to 155 right here. Okay, that's 145. All right. Okay, we want to approximate the relative frequency of the fifth class. So which one is the fifth one? So that's 1, 2, 3, 4, and 5. All right, so this is my fifth one. The fifth one here, if you look at this one right here, it probably somewhere right here. Look at that. It's less than 0.1. Okay. And more than in the middle of 0.05 to 0.1 in here. So if I estimate this one into 0.08 or even 0.09 will still be counted correct, basically. All right. So you can estimate this one is more than a half in the middle, so we 0.08 or 0.09. Okay, number 14. This one is called stem and leaf graph. Okay, stem and leaf, you use this one is called a stem. Okay, the left side is called a stem, the right side is called a leaf, and using a bar separate in the middle. If you have a shortest stem and leaf, the first number will be the minimum, the last number will be the maximum. All right. So look at it. Look at this key here. This one is called 11.9. So that this right hand side is the integer, left hand side is the integer, right hand side is the decimal point, right? So look at this one right here. This will be 17.7. And the maximum will be the last number in here. So this last number should be 17.8 according to this key here. And the minimum should be the first number, which is 11.6. Okay, so A will be the correct answer that way. All right, this is called a stem and leaf graph. Very easy to organize and easy to do it as well. Anyone has any questions? If you want me to explain like the concept one more time, please let me know, okay? Otherwise, we're gonna move on. Let's see if any chat in here. Okay, all right. We do have some people answer the question in that, which is good. Okay, number 15, we want to explain the difference between the class limit and the class boundary. Okay, look at this one right here. We just found the class limit and the class boundary earlier in here. All right, let me go to look at this one. Okay, so what is the class limit and the class boundary in here? Class limit is in this one, this is 50, 50 is the class limit. 53 is also the class limit, right? So this is a lower class limit. Left side is a lower class limit. Right hand side is the upper class limit. So this class limit separate each class, okay? My first class limit is from 50 to 52. So 50 is a lower class limit, 52 is an upper class limit, all right? So the class limit is within a class, that kind of thing. And the class boundary, okay, class boundary is kind of you add and subtract for the on the lower side and the upper side, okay? So if you subtract this one right here, this will be 49.5, okay? So that's my class boundary. And then this add a 0.5, this will be 52.5, okay? And then look at this one right here. If for my lower class, this one minus 0.5, I will also get a 52.5, okay? So the reason we use the class boundary, so the first class will connect to the second class because now you have this, so this will how the graph look like. Okay, let me kind of giving you a little bit quick example. All right, so this, if I have something middle in here, and then this start with 49.5, right? 49.5, okay? And then my second class here is 52.5. Well, actually, this 52.5, if you're using the class boundary, gonna connect with the second class. And then this frequency here is 5. So I graph the 5 in here. Okay, so this frequency is 5, right? My second class frequency is 8. So if 8 is right here, okay, and then this is my second class frequency. All right, so you can see now my first class is exactly connect with the second class in here. And this one usually used to graph the histogram, okay, which we're gonna talk later on. Histogram usually using the class boundary. So histogram graph basically is the bar graph without a gap. All right. Why it didn't have a gap? Because you use the class boundary on the x-axis. So one bar we are next to the other. All right. So that is the difference of the class limit and the class boundary. Okay, another type of graph, this is called stem and leaf plot, and then this is called a dot plot. Okay, DOT, the dot plot. So if you have a number, you put a dot on the top of the number line. Okay, so for example, this one you got 272, so you put 2 dots in here. This one you got 367, so you put 3 dots on the top of 67. So that's called a dot plot. And how do you convert this dot plot into stem and leaf? Okay, so let's see A, B, C, D, which one will be the correct answer?
D.
All right, let's take a look. So what's the minimum for this dot plot? Minimum is on the left
60.
hand, 60. Okay, so if you look at this one, this is 60, this one 50. So this is gone, this is gone, right? So A is incorrect, B is incorrect. The only thing possible answer here is the C or D. All right. And I usually look at this one. I also like to look at the maximum because those two are easy to identify. If I look at the maximum here, it's 81. Yeah, 81. So they both have 81, right? And then I look at the tallest one. So the most frequent one, which is this one right here. So this one, the most frequent one is 67. So I still have 367 in here. And then look at this one right here. This one got a 368, so that is incorrect. Should have a 367. So this one is the correct one. You don't really have to check everyone. You check the most obvious one, right? If you check the most obvious one, I already can choose the correct answer. And then, of course, if you want to check everyone, that's fun, but that will be much slower. Okay, so you check the minimum, maximum, and check the most frequent one, and then the rest are all incorrect. That kind of thing. So yeah, D is the correct answer. Okay. Okay, number 17 and 18, in order to do this one, you will need to use the calculator to do the graphing, okay? And I'm going to show you the calculator to do this one right here. This is you know represent alcohol-related driving fatalities in thousands in US over 20 years period, okay? Using a time series chart to display the data and then describe the trends, okay? Trends, that means is this data gonna be increasing or decreasing? Okay, even I don't do the data, I can really kind of look at it, 25, 23, and then go up a little bit, 24, but look at this one right here, like consistently going down after just a little bit peak on this 87, 1987, right? So basically, even if you don't do the graphing, you can really pretty much say, over the time, actually the alcohol related driving fatalities actually is decreasing. Okay, it's decreasing. All right. If I want to using the graph, let's see. I will show you how to input in a TI-84. Okay, so go to stat. Remember, this is statistic class, so everything with STAT is our favor. All right, so I'm going to stat, and then edit here is input the data. So we're gonna hit enter. All right. I already have some data here, but I can clear this one really quickly. I don't have to clear one by one, right? If I go to clear one by one, it's really slow. So I go to the very top, hit clear, enter, everything will be gone. Okay, same thing as this one. Go to the very top, L1, and then hit clear, enter. All right, everything is gone. So now we can re-input the data in here. Okay, so this data is from 83 all the way to 2001, right? And it increases every other year. So it's all odd number. Okay, so I can input this one is 1983, 1985. Okay, if you look at the pattern in here, 1989. Okay, so from 83 to 2001, this kind of thing, that one. Okay, so we input this one right here, and then we're gonna have this data here. Okay, let me okay, switch this one. So the data here, cursor to the L2 in here. So we have a 25, 23, 24. Okay, and then okay, so make sure when you input the data, your L1 and L2 has to be a same number, same length, right? So this one right here in L10, and then this one right here is also in L10. You cannot have one side is longer or shorter. You have to pair them together. If you don't pair, you won't be able to graph. Okay, so just make sure you two columns are paired at the same length. All right, now we're gonna go back to do the graphing. If you hit second more will be the quit, right? Anytime you want to exit this blue color, you have to hit second first. So second more is quit. Back to my main screen. And then we're gonna do the state plot in here. So second y equal to will be the state plot. Okay, and then we hit enter. D4, this one D4 is off, so we want to highlight the on and enter, so that will be on. Okay, the first one here is called a scatter plot, which we use a lot. All right, and then I want my L1 on the x-axis, which is the horizontal one, my L2 on the y-axis, so that is the D4, so, that kind of thing. So that's exactly what we want in here, okay? You can do the marker as a square or plus or cross, it doesn't matter. And if you don't have a color to change, that's fun as well, but I'm gonna just play this one right here. And then we hit graph, all right? Sometimes when you hit graph, it might not showing up right away. So you need to go to zoom, okay? Zoom anything with the STAT is our favor. So that is number 9. So I'm gonna hit number 9. All right, now you can see this graph will pop up in the screen nicely that way, okay? It will fit into your data set that way. So using zoom state. All right, so apparently this one, yeah, this ear pop out a little bit. So this is kind of a curve that a little bit, but in general, this trend here is if I do a regression line here, this is going down. Okay, so you can see like this one over the ear, it is decreasing. All right, any question about the graphing? That's why we recommend the TI-80 84 because it have all these D4 graphing, right? And then if you use this one right here, number 18 will be pretty similar, okay? And then this one, even you don't graph, you can see the data is also decreasing. Okay, this one is also decreasing. For this one is even obvious, 42, 30, 25, 25, 23. So this is decreasing, okay? All right. Number 19, find the mean, median, and more for the number. So what is the mean? Mean, that means you want to add all these together, right? Add all these together and then divide the number. So how many number do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so I add all these together. I add all these together, add all these together, and then divide by 10, divide by 10. So that would be the mean. All right. But I can show you from the calculator, there's another easy way to find the mean here. Okay, so what is the easy way to find the mean? Well, I go to state. Instead of typing the data on the addition one, I'm going to using the list. Okay, so I'm gonna go to edit, and then I'm gonna clear this whole thing off because I don't need it anymore. And the default usually is on L1. So if you default in L1, you don't have to change anything. All right, so let's go ahead input this 10 data. Let me move this one. So the data here is 65. Okay, so look at this one right here. I input into my L1 here, and then this one cursor to L11, right? So that means I have 10 data. Okay, use this one step, it will calculate the mean for you. So I don't have to using the addition and plus if I input one of them incorrect, I can just cursor back here to change it very quickly. I don't have to re-input the whole thing because sometimes you use the addition one, you pretty much have to input re-input the entire thing, right? All right, so I'm going to stay again. This time I'm going to the middle one using the calculation, the cal. All right, this one variable statistic will generate the mean. Okay, so I hit enter. Look at it, my list here is in L1, it's already default L1. If you happen input into L2 or L3, you can just change. Okay, you can just change the second 3 will be L3. All right. Or if you have a second 2 will be L2, right? If you input your data into L2, you do not need to erase everything to re-input. You just change it, you L1 or L2 here. All right. But the default usually is on L1. So I changed it back to L1. All right. And then we just go ahead, hit a calculation. So this X bar here is the mean. Okay. X bar here is the bin for the 10 data. And then this one also showing you N is 10. So, I input the data. The good news is this one step calculate everything, not everything, but a lot of things. It also telling you the minimum here is 58, and the fourth quadrant is 60. And then if I scroll it down here, look at it. If I scroll it down, MAD here is the median, which we want to find a median for this one. So this calculator step will find the median, find the third quartile, find the maximum for you. Okay, so this is called a phi number. Phi number, which we usually need in the 2.5, the last section, which you do the phi number plot. So this is the phi number. You grab the minimum, Q1, Q2, Q3, and maximum. All right. So there's another question right here. You want to find the median, right? If you do not use the calculator before you find the median, you must line up. You must line up in the ascending order. So you will need to line up like a 59 and then 60, right, in the ascending order, okay? And then actually I have a 58 in here. Okay, so that's a 58. All right, so you need to line up exactly in an ascending order. And then since the n here is 10, 10 is an even number. So that means if you put this one, you're going to have a 5 to the left, 5 to the right. And then you're going to have to go to use the middle two, add up together, divide by 2, right? So that seems a lot of work for this one. But if I input into calculator, input into this L1 in here, right? Input into L1. And then I just go to state using the calculation one state variable. And I can calculate I can find a median right here, right away. Okay, I can find a median is 64. Okay, you also find the more. So the more here will be the most frequent one. Okay, so let's see, do we have any more in here? Okay, so I have a looks like I have a 65, right? And then I have another 65, I have another 65. So I have a 3 of the 65. The rest, I don't really see another 3 repeating. So 65 will be the more. 65 is the more because it appears the most one, the most frequent one. Okay, anyone has any questions so far? Okay, number 20 is this is top 14 speed in miles per hour or mph, right? For pro stock drag racing over the past 2 decades, listed below, find a median speed. So median, well, you got how many do you have? You got 14 of them, 14 of them in here. So if you do that manually, you will have to go to line up together. Okay, this one is not in the ascending order. So if I were you, I might just go ahead using the calculator, which is much easier. Okay, so if you input those 14 data, go to stat, edit. All right. And then this time, if I want to input into L3, I can input into L3, right? And then just input all these 14 data in here. Okay. So I'm going to just using the L1 since just for demonstration only. Okay. And then you go to state. After you input, you go to state, go to cal, and then using the one variable state. If you input into L3, change this one into 3. Okay, change that one into L3. And then you can just do the calculation. So that will give you the median in here. All right. So it's much easier to do this one in a calculator. Okay, 21. The mean score of the contemporary test is 70. Standard deviation is 6. We want to use the empirical rule to find the percentage between 64 to 76. Assume the data set has a bell curve. distribution. So if you look at the formula sheet in here, okay, let me pull out the formula sheet. If you pull out the formula sheet in here, this is called an empirical rule. Look at it. The empirical rule in here, about 68% of the data will lie within 1 standard deviation, 95% will lie in the 2 standard deviation, and 99.7 of data will spread between the 3 standard deviation. Let me tell you one thing. I did skip the several data theorem. So because this several data theorem is using for non-Bell curve, non-symmetry. All right. And non-symmetry, we don't really use it for the later chapter. So I cut this part off. So our requirement is only the empirical rule, which is the Bell curve. Okay. So before you do this one, you will need to be able to give it a drawing for the Bell curve. Okay, even it's not a pretty, but you can have a sketch. All right, the mean is always in the middle, right? So the mean will be in the middle. Mu, the mean here is called mu. Okay, mu here is 70. Let me see if I can get this one look a little bit prettier. Okay, so mu here is equal to 70. All right. Standard deviation, we usually using sigma for the population. Okay. Sigma here is 6. All right. So 1 standard deviation, that means we have to plus minus 1 standard deviation is 68. So 70 minus 6, you're going to get a what? 64. Okay. 70 plus 6, you're going to get a 76. All right, so what does that mean? That means between 64 to 76, you have a 68%. This is called within 1 standard deviation, right? According to the empirical rule. So between 64 to 76, you have 68% of all this whole thing. Actually, this is exactly what we want. Look at that. Use empirical rule to find a 64 to 76. So that's exactly 68. So we already done in here. All right. If I want to find a 2 standard deviation, so what is 2 standard deviation? That means I have to minus another sigma here. So if I minus another sigma here, that would be what? 64 minus 6. That would be 58. Okay, that'll be 58. And then this one, you're gonna add another standard deviation. 76 plus 6, that will give you 82, right? All right, so what does that mean in here? That means between 58 to 82. Okay, this whole thing here will be 95% of the entire bell curve. And the total bell curve is 100%. Okay, so this one is already 95%. 95% in here. All right. So if you look at the bell curve, the majority is in the middle, right? So look at the fourth standard deviation. Only addition and subtraction for 1 standard deviation, you already cover 68%, which is more than a half already. All right. If you have a 2 standard deviation spread out, you already have a 95%, which means the rest is only 5% for the rest of them. All right. And then if you have a 3 standard deviation here is 99.7%. Okay. If from here to here, that would be almost cover the entire bell curve pretty much. This one will be 99.7%. All right. And then you're gonna add a 6 in here. So 82 add a 6, so this will be 88. Okay. And then 58 minus 6 here, this will be 52. All right. So between 52 to 88, you have a 99.7%. All right. So that means the rest of this tail and plus this tail added together is only 0.3%. Okay, so that's how you use the empirical rule. Okay, that's why I did recommend people to go ahead and print out this page, okay? But you kind of want to know how to use these three rule, empirical rule, called empirical rule in here, okay? This one probably sometimes people consider the most challenging one for this test or for the unit one. Okay, any questions? All right, let me go ahead pull out this empirical rule from the book. Okay, so this is the empirical rule in here. All right, so the mean here is in the middle, right? And then you minus one standard deviation plus one standard deviation, that's 68%. Okay, and then you minus two standard deviation and then plus two standard deviation, that's 95%. And then you have a minus, using the mean minus three standard deviation and using the mean plus three standard deviation, that's 99.7. So the rest of this tail, the right tail, and this is left tail, each tail only half of the 0.3%. So each one will be divided by 2 will be 0.15. Okay. You don't have to remember all these little detail, but you should be able to use this three big number to calculate all the smaller one in here. Okay, so this three number is the key thing. Okay, so 22, that's using that bell curve again to calculate this one. Okay, so that's another bell curve. The SAT verbal score is 462, standard deviation is 98, right? You want to use the empirical rule. So what's the empirical rule? That one, the one I just showed it to you. This one is called the empirical rule, 68, 95, 99.7% rule. And then this one even explain you the detail, what is empirical rule. All right. So you're gonna use those three numbers to answer this question. Okay, so we can go ahead drop a little bit bell curve in here, even it's not that pretty, but the beam here is in the middle. So my mu here is 462. Okay, and then my standard deviation here, sigma here is 98. All right, and then you want to find a percentage of the score either between 462 to 560, right? So 462 is exactly in the middle. So we only need to add to the right. Okay. So if I add one standard deviation to the right, how much is that? 462 plus 98 will be what? 560. Oh, it's only one step is already done. All right, so this is only adding one standard deviation. So this is plus one standard deviation only, plus one sigma. Okay, bell curve is symmetry. All right, bell curve is symmetry in here. So if I add or subtract one standard deviation here, this whole thing is 68%. 68%. But I don't need the whole thing. I only want to calculate from the middle to the right. So from the middle to the right will be half of the 68%, right? Half of the 68 will be what? 34%. Okay. So if you look at this bell curve in here, from here to here, from the middle to one standard deviation to the right, yeah, that's 34. Okay. But you don't really have to have this one to answer that. If you understand the 68% is one standard to the left, one standard deviation to the right. Okay, and then you only need a half of them, so that's 34%. Any questions? If someone quite get there, you want to go ahead speed that up. Okay, 23 here is calculate the GPA. Okay, The grade point average here, A is 4 points, C 3, B is 3 points, C is 2, D is 1, F is 0. Okay. Grade are weighted according to the credit hour. So if a student receive a A in a 4-hour credit class, D in a 2 credit class, B in a 3 credit class, and C in a 3 credit class, what is the student's semester GPA? All right. I usually tell statistics students that you need to be able to calculate your own GPA, right? Sometimes the system may not update immediately. And if you want a transcript, you want to see like if the system update your grade or not. All right. If not, you might have to wait a couple more days or something like that for the system to update the GPA. I don't know the system right now, but in the past, the district only update the system twice in a semester, right? And then if you have a shorter semester, you might want to see if your GPA got updated or not. Your grade might be already there, but your GPA might not get updated right away. Okay. So you need to be able to check your own GPA. All right, so the GPA here is a weighted bin. So let's go ahead and look at the weighted bin formula. Okay, so if you go here in here, we have this chapter 2, we have this weighted bin. This is the formula, weighted bin formula. That's the one you can calculate your GPA, right? Big sigma is the sum. So you're gonna using the grade times the weight. Weight is your credit hour. So each grade times the credit hour, and then add them together, and then divide by the sum of the credit hour. Okay, so that is how you calculate this one. I can also show you later on how to calculate in the calculator as well. But let's do the manual one first. Okay, sigma of x times w over the sigma of w. All right, so let's see how many classes we have. A in a 4 credit hours, so A is 4 points. Okay, 4 credit hour, so this is also 4. Okay, and then I'm gonna add a 4 credit hour in here, okay, in the denominator, so I don't have to go back another time. D in a 2 credit hours, so D here is just 1 point. All right, so 1 times 2. Okay, and I also plus 2 in the denominator. All right, and then B in a 3 credit hours, so B is 3 points. Okay, so B is 3 points, and then a 3 credit hours, so I have a 3 credit hour. Okay, and then C in another 3 credit hours. C, you only got what, 2 points. So that's 2 times 3. All right, and then I add a 3. Okay, so let's see how many credit hours the student taking. 6, 9, 12, right? So the student taking 12 credit hour totally in a semester. And how many points does student earn totally? So you need to multiply first before you add them. So that's 16 plus 2 plus 9 plus 6. All right, let's see how much do we get. That's 18, 27, 33, right? 33 over 12. So 33 over 12, you can simplify by 3. Okay, so that's 11 over 4. 11 over 4, that is 2.75. Okay, so that's the student's GPA, 2.75. All right, so that is how you calculate by hand, right? That's the student's GPA. You can also calculate this one in a calculator for the weighted bin. So that's why I recommend the calculator using the TI-84 because you have a lot of built-in. Okay, so weighted bin here you will need to input into 2 columns. So the first column here you will input the grade A, B, C, D. And then the second one, you input the hour. Okay, the second one input hour. So let's see how we do this one. Create this one in here. A in a 4 credit hours. So A, you got 4 points. Oh. All right. So I like to, since this one, I like to input this 4 credit hour in here. Okay, so that way I don't have to come back mismatch. All right. D in a 2 credit out. So D, you only get 1 point. All right. And then this one is 2 credit class. So that's for D. All right. So I want to input this together so I don't mismatch. Because if you mismatch, it will be different. B in a 3 credit hours, B is 3 points. Okay, and then this is 3 credit that way. All right, and then hold on, that's the tricky part. C in a 3 credit hours, C you got 2 points. Okay, and then that's 3 credit hour. Okay, and then I think that's it, right? 1, 2, 3, 4. Yeah, 4 courses. Okay. All right, so that is L1 and L2. L2 is the weight, okay? And I am going to come back here to the state, doing the same calculation using the one variable state. My first one here should be L1. Okay, usually that's in default in L1. And my frequent list, if you everything only appear once, you don't have a second column, you only have a default list frequency will be just once. But we don't have a we have a weight in a different class. So you're gonna input a L2 in here. So second two will be L2. And if you calculate this one right here, it will give you the weighted bin, not just the simple bin. Okay, so look at that. I calculate this one, I got a weighted bin, it's 2.75. Exactly the same as we did it manually. Okay, exactly the same we did this manually. All right, so this grade is only 4 courses, so it's easy to do it by hand, right? If you got 5 or 10 classes, calculator will be much easier that way. Okay, any questions? Okay, so this one right here, you want to approximate a sample bin. Okay, the manager of the bank recorded the amount of the time a random sample of the customer spent waiting in the line during the peak business hours on Monday. The frequency distribution summarizes the result. You want to approximate this table's sample bin. Okay, so this one, the difference of this one and the other one here is this one, you have a waiting time, right? You have a lower class limit, upper class limit, and then this is kind of like a frequency. The number of the class is like of the customer is kind of like a frequency, or the one we say the weight. Okay, depends on which formula you use. But these two formula actually is pretty similar. So if you use this one, okay, the weighted bin, this one, uh, or the bin of the frequency distribution. Actually, these two are pretty much similar. This n is the sum of the frequency. Okay, so these two formula, the weighted bin and the bin on the frequency distribution, actually these two, in my opinion, is very similar because this n is the sigma of f, right? And then that kind of thing. So you have a denominator is the sigma of that. So these two formula is pretty similar. All right. And this one, apparently, if you use a calculator, it will be a little bit easier because this got so many, 1, 2, 3, 4, 5, 6 classes. No, seven classes. So using the calculator will be a lot of easier. All right. One thing here is you do need to find a bin point first. You need to find a bin point for each class before you can put in a calculator. Okay. So how do I find a bin point? The bin point here is the middle of the 0 and 3. So if we're using 1, 0 plus 3 divided by 2, we're giving you 1.5. Okay. And then look at this class width. So you can do each class one by one, doing that way. 4 plus 7. 4 plus 7 is 11. 11 divided by 2 is 5.5. But this calculation will be much slower. If I look at the class width in here, 4 minus 0 is 4. 7 minus 3 is also 4. So that means this table class width is 4. So if I find a fourth class beam point, I can just add a 4, right? So this add a 4 will be 5.5, add a 4, this will be 9.5. So it's very easy. And then add a 4, this is 13.5. All right, so that's why I'm going to use, and then I input a calculator. Okay. All right, so let's clear everything in here. Go to Stat, Edit. Okay, and I'm gonna reuse my L1 and L2. All right, let's input this one. So the first one here is 1.5. And then you just add 4 on all of them. Okay, 9.5, 13.5, 17.5. Oh, this one plus 4 should be 25.5. Okay, and that is 7 classes. All right, and then the frequency here, this will be 12. 12. All right, so that is the frequency. Okay, I just showing you this table in here, right? I input the beam point on L1, input a frequency on L2, and then we just go to Stat, do the calculation. One variable stay in here, and then I already have L1 and L2 in here. All right, I just hit calculate. And that's it. This is my weight bin. 9.07, that is my weight bin in here. Okay, and then let's look at the choice for the um all right, so this one you got round to 1 decimal point, so that'll be 9.1, right? So you have a 9.07. Anything 5 or above, you round up. So this round up will be 9.1. All right, so you can see using the calculator here will be really straightforward. Questions? Okay, this one you want to find a sample standard deviation. Look at it. This one telling you is a sample. So if you sample, you want to using the X. Okay, if the population, you're using this sigma. All right. So if you don't want to do this one by hand, guess what? You can put this whole thing into the calculator, and you can find a sample standard deviation in no time. Okay. So let's go ahead and do the sample standard deviation from here. So you go to Stat, Edit, all right, and then we're gonna clear everything in here. We can reuse this one. All right, so this one is gone, and then let's input the 15. Okay, so we input this whole number in here, and then you just go to Stat using the calculation, and then using the one standard, one variable statistic. This time I do not have a L2, so I have to clear out this L2. Okay, otherwise it will give me my error message. And then I just hit enter and then do the calculation. So this x, this is a sample standard deviation. This is sigma x is a standard deviation. All right. If you scroll it down, you got more information right here. We take that earlier. This is median, fourth quadrant, third quadrant, that kind of thing. All right. So the one I want to do here is the x of x. Okay, this is the standard deviation for the x variable. So that's 17.8. okay? Because this one is says sample, so I need to do anything with the X, that's a sample, all right? So this sample here should be 17.8 in here, all right? So look at this one right here. 17.8, right? We have a 17.8. If you answer the 16.8 in here, that'll be the wrong one, okay? All right, 26 is another empirical rule, right? So the adult, the mean IQ score for the adult is 100, standard deviation is 15. You want to find a percentage between 70 to 130. So we can go ahead create a bell curve, all right? And then the middle one is 100, standard deviation is 15, okay? So you can just go ahead and subtract like the number until you reach 70, right? So if you minus 15, you got 85, okay? You have to minus another 15 to get a 70. So this is 2 standard deviation away from the middle. And then 130 will be right here. You add one right here, that's 115, and then add another one, that's 130. So this is also two standard deviation to the right. So this one is pretty easy. So that's two to the left, two to the right. So that's 95%. All right. So once you're familiar with the bell curve, actually it's pretty straightforward. Okay, another one right here. So this one you want to be between 53 to 77, right? Same thing, drop a bell curve. Middle one, the mean here is 65, okay? Standard deviation is just 4, all right? So we're gonna add and subtract until we reach these two numbers, okay? So if I subtract 1, I got 61. I subtract 2 standard deviation, I got 57, right? And then we have a 53, so I have to keep going. So, so this is a 3 standard deviation to the left. And then let's see 77, so that is 69, right? And then plus another 4 will be 73 plus another 4, you got 77. So how many is that? This is exactly 3 to the left, 3 to the right. So that should be 99.7. All right. Okay, another bell curve. So you should be by the end of the review, you should be really familiar with this one, right? So we're gonna drop another bell curve. Okay, drop another bell curve. All right, it doesn't matter, even it's not so pretty, but you can just get an idea, right? This mean score is 490, okay, 490. Standard deviation is 96. I have to write down these two numbers here, so I don't have to go back to question again and again. And then 298, okay, 298. So if you minus this one right here, that'll be 394. Okay, and then you have to 394, you have to minus another 96, so in order to get a 298, so that's 2 standard deviation away. So this one is 2 standard deviation away. And then let's see what is 586. Well, 586, if you add this one right here, that's already 586. All right, so now this one is not quite exactly symmetric. But if you look at this one, plus 1 standard and minus 1 standard deviation, this one is 68% already. Okay, this one is 68%. All right, so that means we have to go to add this piece in here in order to get a total. Okay. All right, so you can say, 34 is incorrect, right? 68 is incorrect because I have a more than 68 in here. Okay, I have to add this one. And how much is this piece? Well, if you have this piece of the graphing in here, okay, Let me pull this one ahead in here. If you have this one right here, that will be really easy. So that's 13.5, right? If you have 68 in the middle and then between this one to this one, that is 13.5. Okay, so how do you get a 13.5? All right, this is 13.5. So you're gonna have a 68 plus 13.5. So that should be 81.5 in here. All right. That is one way because if you look at the two standard deviation away, that should be 95%, right? Let's assume if we do not know that one's 13.5. So that's 95%. Okay. 95%. And then half of my 95%, half of my 95% here will be 95 divided by 2. Will be 47.5. 47.5%. Okay, that's percent. All right, and then from middle to here, this is half, so that's 34%. All right, so now you have a 47.5 minus 34, so that's exactly giving you 13.5%. So even if you don't use the other bell curve, just using these three numbers, you should be able to figure it out. Okay, a little bit add and subtract in here. Any questions? Okay, this one you want to approximate a sample bin, all right? So this is kind of a little bit repeat to the previous question, just giving you one more exercise. So basically, you also need to find a bin point first, right? If you look at the class width in here, this is 10. 10 is the class width, okay? So if I just find the first class bin point, I add a 10, the rest will be done, all right? So 30 plus 39 is 69. 69 divided by 2 will be 34.5, okay? And then it just add a 10, so this one will be 44.5, all right? And then just add a 10 for all the rest of them. And then you type this one, so this type into L1, this type into L2, right? And then you just using one variable state, and then you should be able to calculate the sample bin. You know, this one is says sample, so you know the sample bin and the population bin is always the same, so you find the X bar. All right, so that is input into calculator. Anyone has any question? Okay, let me just go ahead and input this one more time for you. Okay, let's go ahead, calculator. So I go to stay here, edit. Okay, I'm gonna clear everything out. And then let's input into L1 here. That is 34.5. All right, and then that's a 3. Okay, so after you input everything, just go to stat, cal, using one variable, and then this time you have to input you weight into frequency list. So second 2 will be the L2, and then we just calculate. All right, and then this will become your weighted bin. Okay, 56.3 is your weighted bin. So pretty straightforward, 56.3. So that's A. All right. Okay, this one want you to drop a box whisker plot for this data. All right, so if you want the box whisker plot, basically you using the 5-number system. So what are the 5 number? One is the mini band, one is the max band, and then one is Q1, Q2, Q3. Okay, so if you find this 5 number and you just plug it, So the minimum is right here, and then you drop a box for the middle one. Okay, so this is the minimum, and then this one is your Q1. Okay, and you Q2 may not exactly in the middle, so maybe somewhere right here. All right, that's your Q2, and then you have a Q3, and then you connect this whole thing to the maximum. All right, so basically this is called a box and whisker plot for that. Okay. The good news is the calculator can also graph this box and whisker plot. Okay, so if I put this whole thing into the calculator, guess what? It will graph it for you. All right, so let's go ahead and give it a try. Even input the data looks a little bit long, but that's okay. We don't need an L2, so we're gonna clear it out. Okay, so let's go ahead, drop the box and whisker plot in here. But you have to input the data first. Okay, so let me input this one. This is showing this way, but actually this is just all one list of the data. All right. So it doesn't matter you go vertically or horizontally, that's all good. So I'm gonna go vertically, a little bit easy for me in here. Okay, so I just input all the 30 data. Look at that, because I'm in a L31. So that means I input all 30 data in here. All right. So if you go to stay in here, go to do the cal one variable calculation, get rid of my L2. All right. And then if we just hit enter, so this one showing you the minimum here is the 31, right? And then the Q1 here is 56. Um, Medium here is 72, Q3 is 83, maximum is 99. So basically, you just plug this file number into the graph I said earlier, but the calculator will also graph that for you. So if I go to second Y, and then I will go to the state plot, right? And then make sure you turn it on, and then I can use this one right here. That's your box and whisker plot, okay? This one is also box and whisker plot, and sometimes people say, what's different of these two? Well, the difference of these two here, this one has a broken dot. So that means this one will graph the outlier. This one don't have a broken one. This one doesn't graph the outlier. So I usually like to use this one better because this one you can graph the outlier. Okay, the one is blinking. This one can graph the outlier. So I like that one. Okay, and then I will just go ahead and graph. And again, if you didn't show anything, make sure you zoom state, okay? Because your data set change. So zoom number 9 is zoom state. So that is my box and whisker plot, okay? And this one, the graph looks pretty good. It didn't have any outlier because it didn't have any broken point. And even I used that. So this one doesn't have an outlier. All right. So that is pretty good in here for this data set. Okay, you can just plug the miniman and then the Q1, Q2, and the maximin there, and that's your box and whisker prop. All right, last two question here is to find a z-score. Okay, this one you want to find a z-score for the data value is 59, mean is 72, standard deviation is 1. So if you look at the formula here, z-score is using x minus mu divided by sigma. Okay. Look at the formula in the formula sheet. All right, you have a z-score. Okay, so what does the x mean? X is the data value, mu here is the mean, sigma here is the standard deviation. All right, so I have this one right here. I have a data value here is 59, so I use 59 minus mean here is 72 divided by standard deviation is 1, right? So everything divided by 1 is still equal to itself. So this one will be negative what? Negative 13. Okay, so that is A in here. So the z-score is negative value. That means this is below the standard, below the mean. Okay. All right, so that is this one right here. Number 36 is also calculate the z-score, but you need to calculate SAT and ACT z-score. So make sure you match everyone. Okay. So you want to match all the ACT and match all the SAT. All right. So let's go ahead look at the SAT first. Okay, since we have a SAT right here. So SAT z-score, you want to use the data value. Okay, this is the mean, this is standard deviation. Let's see what's the SAT data value. SAT data value is 660. So we want to use the data value minus the mean, okay? And then divided by the standard deviation, that's 113. And then look at the ACT. All right, ACT here is ACT data score here is 27. Okay, and then the ACT being here is 20.6. Let me use a different color. Okay, so ACT here, this is 20.6. Okay, and then the ACT standard deviation here is 5.1. 5.1. All right, and then you just go to calculate these two. These two look like both are positive number. Okay. If you go to use the calculator to do the calculation, this one is about 1.29. Okay, and then this one is about 1.25. All right, since my data value both are positive, that means the higher the better, the big number the better, right? So apparently this student doing better in SAT because the G-score is higher in this case. All right, so I just go through the very, very detailed review for all this chapter in this unit, actually, include how to use the technology, the TI-84, okay? Any questions? Anyone has any questions? Any questions about unit 1? So you let me go ahead showing you where to do the unit 1 test. According to the college, which we require to use the this is called what I call lockdown browser. Okay, so everyone will require the lockdown browser in here. So if you go to the course, okay, and then Okay, let me do the student view in here. Okay, if you go to the entire course today, right? So I set up this one right here, the sample lockdown browser test. So, maybe you can just give it a try, right? So before you open the test, let's try you lockdown browser to see if it works. That kind of thing. This one you can try as many times as possible. All right. That kind of thing that way. And then you might need to install a little bit of lockdown browser software. Another way to look at this one right here is the if you go to the lockdown browser in here, okay, if you go to this lockdown browser, and it will tell you a little bit more how to get started, and then there's video tutorial introduced with lockdown browser in this case. All right, so that way it will giving you a little bit a quick start that way. Okay. All right. Anyone has any questions? Any questions?
Yes, I have a
Yes.
question. How long is the test going to be?
2 hours.
Okay, and then how many, like, is it 1 through 50, 1 through 25?
Usually it's around 20, around 25. Yeah.
Around 25. Okay, and then
Yes.
we're allowed to print off
Formula sheet. Yes.
the formula
And
sheet, and then we can
yeah,
use. I
you
have a
can use
question.
it. You can use a calculator as well.
Okay, my phone, I just downloaded that app. Can I use that, or do I need to get the T84?
As long as you show the screen, like I said, that is the app, right? And then you show the screen, say that's the app, but you're not going to anywhere, just using the app. That's okay to me.
Okay.
Yeah. Because I know it's much more economic to buy the app than the handset.
Yes. So as soon as I start to test, I just show you that I'm on the app,
Yeah,
correct?
on the TI-84 app.
Okay.
Yeah. Mm-hmm. Yeah, that way we know like you do have an app in a cell phone that way.
How many questions will be on the test?
About 25.
You said 25 or 35?
25, 25.
Okay.
On average, I can open the question just to make sure very quick. Actually, I don't mind showing you how many questions we have. Let me go to, if you want to know exactly how many questions, I can just launch that very quick. Because some tests might a little bit more, some tests might a little bit less. So, but the first one, let's see. Okay, actually it's only 19 questions. All right, not 25, 19.
And we have
You have 2 hours to
time.
complete.
2 hours? Okay.
Yeah. And then there's a formula here you can download and print it out. So if you go to the module in here, okay, if you go to the course module, and you will see the formula, the key formula in PDF. So I already, this one actually is in the digital textbook, but I kind of just download it, organize it for you already. So you can just click here and download and print it. The test one, you only need a page one, because the rest you don't need it. You only need this page, the formula.
I have a question. Do you recommend just studying over
First, you have to finish all the homework assignment because homework itself counted as a grade, right? So that's the basic one. You must finish the homework for sure.
I know, but for the test, because I just did the quiz, there's some stuff that it's similar, but it was a bit hard. Like I had to go to the lab or the math lab.
Mhm.
There was some things that are just very similar. So I just didn't know the best way to study. Sometimes when I just study the homework,
Mhm.
I don't really get that great of a grade.
Okay, so after you finish the homework, you finish the online quiz, right? Because those and also the review, that one, and then I will go through our review tonight. We just you want to, even you hear that one time, you might not really be able to do that on your own. So I would recommend you to, I think that one is also the question. Let me see. The question should be posted somewhere. Key formula sheet, introduction. Okay, let me see. Okay, I will just make sure I also post this review question. Let me after
Okay.
class, I'll post a review question. So you might want to go through this one more time. That way,
Okay.
that giving you most of the concept that way.
Okay.
So
So basically rewatch these review videos. And
well,
then,
you don't have to, since you attend a class, you don't have to watch the entire video again. But after I post the review question, you might want to go through those review questions on your
okay.
own, trying to see which one you understand, which one you don't. And if you don't, if you want to watch the video, you don't have to watch it from beginning to the end, right? You can just click, skip and then move to the question you want.
Okay.
That will,
Will you
that
make a
will
review for chapter 1 as well?
Yeah, this review also includes chapter 1. Yeah,
Okay.
but
Thank
this review, like I said earlier, this review is not guarantee 100% complete, but giving you the key concept, that kind of thing, right? You number gonna be changed, your question type gonna be
Yeah, of
changed a
course.
little bit. That kind of thing. In math, it's very hard to find the exactly same number per se, that kind of thing. Unlike a history, so everything, this is the location, this is the day and time, everything is the same. But that isn't the case in math. But
Okay.
yeah, but the concept, the principle, the concept you use will be pretty much there.
Okay.
Can I just say that I've already taken the test and I've found a lot of help from the tutors that are available in Canvas. The
That's
net tutor in
mhm.
specific, if you just click it and then go find statistics, you'll get a tutor that pops up fairly quickly and you're just one-on-one with them. So you can ask them questions with the way your brain works. And those tutors online, the online tutors have been so helpful for me.
That is great to know because sometimes some people told me, say they have a online tutor in the past. I got a lot of feedback, say hard to reach that way. But I'm great to hear like the online tutor is available, so that's good news.
Yeah, I've been able to actually understand. I was so afraid of this class when I first started, and those tutors have really, I mean, I can't even put into words how much they have helped
Right.
me.
Because yeah, we do have a lot of full-time tutors there. So yeah, you want to take advantage of that, and plus it's free for students. So you
How
really, if
long is
you
the tutoring?
you can tutor, you can usually as long as you need.
Yeah, they
Okay.
tutor with you for a while. I
Okay.
haven't had any limits. You just you can go in there and they have the sheet set up to where you can like put the exact question. They're good about not giving you the answer, but like helping you work it out to where you can get to the answer.
Oh,
So I mean they really will work it step by step to where you start with point A and you get to point B, but you understand how you get there. And it's just been so helpful.
okay. Thank you for sharing that.
Yeah, of
I think
course.
it's tomorrow I have a tutoring with them because the map or
Yeah.
the, I get off later and the,
Yeah, and usually statistics is new to a lot of people. Even some people are really good at algebra, but when it comes to statistics, it's a brand new one. So yeah, you do need some help for that.
Mhm. I have another question.
Mhm.
Do you have any, like, if someone fails the test, is there any like extra credit, or do you do makeup test, or I know sometimes some professors do that, so I wanted to ask.
Unfortunately, this course is a very fast course, so we don't really have time. I do have some remedy in the past, but that's for a little bit longer semester that student can actually do a project, to make up one test, but not a whole, not the entire semester that way. But the project, in order to do the project, you really have to accumulate a little bit of statistic in order to be able to do the project, that kind of thing that way. But since our class is so fast, by the time we finish, we pretty much had to turn on the grade right away. So leave a very, very little time. But if people can still do that, if you can still find a time to do the project, as we described in the fourth class, you go through those 5 steps, you submit a topic, you correct the data, you do the statistical analysis, and that way we are giving you and if your project is score higher, you can replace one of your tests. Okay.
Okay.
Yeah, but
Where do you set?
it's just one of the tests. It won't be replace the entire you test, that kind of thing.
Where does she found the tutorial?
Right now you don't have a. I don't recommend you to do the project right now because we haven't learned enough statistics, and I'll post some kind of samples project later on. Like a student in the past, they do the project, and I keep some of them. Some of them a little bit better, so I keep them, and of course I remove them, and then I post the project so you can have a reference that way. All right. Any other questions? Okay, so at the beginning, you really want to focus on the don't try to rely on the project. That would be pretty much the later on, that way, So at the very beginning, because you have a 4 test, even a project can only replace one test, right? So you really want to focus on the course, that way. All right. If not, I'm going to stop the recording and let you go for tonight. You can still inbox me if you have any question come up. Okay. Um, and then, like I said, this is a pretty fast class. So once you finish the test on Monday, you don't want to take a break. You want to move on to chapter 3, okay? Because next week will be week 3, and we have a 4 test. So if you use 7 divided by 4, what does that mean? That means, you know, uh, a week and a half, we need to finish one unit test that way, right? So that's how fast the course going. So you really need to focus on that, and then by October 12th, everything will be done. So this is September 6th. So you have a month and a few days. You will finish one course. So it is very fast. Okay.
I have one question quickly. Um, so will this class just keep kind of building? Will it, or will we be learning just different, like after this chapter test, is it something that like it's just going to keep building? So if we don't do very well, does that just kind of mean that it's going to be super difficult?
Okay, so that's the good news with statistics. Unlike algebra, or calculus, you have to kind of build on a chapter by chapter. The good news is statistics is kind of the new chapter. You pretty much start over again,
Okay.
with the new chapter, new concept. And so even you do the chapter only one test really well, the chapter 3 new concept again. So you still have to learn a new concept. So that's bad news or good news. The good news is if you don't do the unit 1 well, you might still be able to do the unit 2 well. That kind of
Okay.
thing. But if you do the unit 1 well, of course, it will help you with some of the concept, right? Because we do reuse a little bit concept, but not a lot, that kind of thing. But not a calculation. Calculation, the new chapter, you're going to have a new calculation. So that's
Okay.
a little bit different than the algebra, that kind of thing.
Okay. Thank
So
you.
a little bit more independent, pretty much. All right, good question. Any other questions? Okay, if not, everyone have a good night. All right, and you can still send me the email if you have any other questions. Okay, and thanks for I will also post the review online. All right, and I'll post the announcement when I post the review. Okay, all right. Good night.
Good night.
Good
Thank
night.
you.
Thank you.